Louis, do you want to go ahead and introduce us? You're on mute, Louis.
Indeed, I am. Technical issues. Good morning, good afternoon, and good evening. And welcome to this session where we're going to unpack privacy-preserving algorithms and the suptech uses. My name is Louis de Koker, and I am privileged to be joined by three experts. Firstly, Carl Herse, who is an intelligence expert and who was the National Manager Intelligence Capabilities at AUSTRAC, that is Australia's Financial Intelligence Unit, where he led the development of the FIU of the future model and worked closely with the developers of this technology. Secondly, Professor Michael Brand, adjunct professor at RMIT School of Computing Technologies and formerly the director of Monitors Center for Data Science. Now, Michael was directly involved in the development of this technology, working with a great team of data scientists. Lastly, but certainly not least, a powerhouse from South Africa, Professor Vivenne Lawack, who is a formidable university leader, currently Deputy Vice-Chancellor academic at the University of the Western Cape, and FinTech, and especially law and FinTech leader in South Africa. Importantly, Vivienne also was in her former career a bank supervisor working with the South African Reserve Bank to provide us with broader suptech perspectives on this technology. But to start us off, I'd like to invite Carl to tell us more about the context in which this technology was developed and specifically the problems that it had to address. Thank you, Carl.
Thank you very much, Louis. Michael, do you want to put the slides up?
Certainly.
So just ahead of the slides being available, here we go. A little bit about AUSTRAC. As Louis said, I'm here to set the scene, if you like, for the motivation for the effort that went into the development of the FinTracer capability that Michael will speak to later on. A little bit about AUSTRAC. If people don't know, AUSTRAC is a little unusually both a financial regulator and a financial intelligence unit in the one entity. That really doesn't have much import into what we're discussing today, but it's useful to keep in the back of your mind. At the time that the effort was made to develop this capability, AUSTRAC recognized a potential problem or a way to increase efficiency in terms of understanding the level of concern around AML and other financial crime matters. In that, whilst AUSTRAC received from reporting entities, IFDs, certain information around cash deposits above a certain level, cross-border movements, and importantly, suspicious matter reports from individual financial institutions, due to the very strong privacy legislation that Australia has in place, and also because of the tipping off provisions that exist in relation to these kind of exercises, and to some extent because of commercial and cultural factors, there's a range of factors that meant that the visibility, if you like, of financial transactions across the entire financial sector in Australia was limited. This meant, for instance, there were silos created around the fact that individual reporting entities obviously can't have access to details of the bank accounts and other reporting entities. They were stopped by legislation from disclosing to others information that might be contained in their suspicious matter reports. And outside of suspicious matter reports, AUSTRAC didn't have wholesale access to domestic transactions within the Australian financial situation. What this means, of course, is there are limited visibility of suspicious matter transactions across the financial system. This creates opportunities for money laundering and other financial crime activity. and importantly, doesn't provide visibility of the entire financial system for analysis. Michael, could you go to the next slide? That's a quick summary. This, for those people who like to see things visually and think in pictures, this is supposed to represent a graph representation of the entire financial system in Australia. What we were able to see was not this picture, but Michael, the next slide, please. Bits and pieces of what was going on, little windows into what was happening. And this enabled the potential flourishing of financial crime. And importantly, I think, in a point that I'll make at the end of this presentation, limited the ability to do system level analysis around the level of risk that was intrinsic in the Australian scenario, if you like. So that's the framework. And with that explanation, I'll hand over to Michael to give you the technical background to the capability that was developed.
Thank you very much, Carl. So Carl showed this in a slide. I will have an entire animation to make this more concrete. So we're going to look at a very simple example of how the fact that AUSTRAC doesn't have any wholesale visibility onto domestic transactions except when there is already a prior suspicion, how that can be used by someone who wants to commit all sorts of financial crime. Specifically, we're going to look at the very simple example of layering, which will be the running example that we'll be using throughout in order to demonstrate the capability. So let's say that we have an account A in some bank that receives money from some known source. So as an example, let's say it's some government assistance. Way back in the days of COVID, the Australian government gave employers some money under a job keeper title, and that job keeper incentive was meant to pay salaries. So you can imagine that this is that kind of money being sent to account A. Now, if account A at this point moves that money to an offshore account with known criminal ties, that's a no-brainer. The bank can immediately submit a suspicious matter report to AUSTRAC, and then AUSTRAC can see everything that's going on there, and all is good, which is why criminals actually don't do this. What they do is they distance themselves a little bit from the source of the money. So let's say that account A doesn't transfer the money directly overseas, but rather to another account B in another bank, which then transfers the money overseas. What happens then? Well, neither of the banks can at this point submit an SMR. The bank managing A can see the source of the money, but the payment to B can be a completely legitimate payment. It can be wages. The bank that manages B can see money going offshore, but they don't know what the source of this money is. It might be part of a completely legitimate transaction. AUSTRAC, best case, will see the first and last of these transactions. So even though we have organizations seeing 2 of the 3 transactions involved here, not a single one of them can connect the dots and see that something amiss is going on. And that's the problem that AUSTRAC saw and decided a few years back to address. And this became a project called FinTracer. And it was designed, obviously, from the ground up to be fully compliant with the Australian legal system. And the reason why we can discuss it now is that it's been recently made open source. So not only can we speak about it, you can actually use it. What it is a convenient to use system for running distributed privacy enhancing algorithms over distributed data sets. That's in a general sense. In a very specific sense, it was designed to run over the set of domestic transactions, which is kept separately in the different banks. and to run algorithms that are useful for AML. And this allowed AUSTRAC to actually gain that security, to close that surveillance gap, in that you can now define typical criminal behaviors in what we call crime typologies. In a behavior-based way, you can define them as though you had the entire transaction graph, as though it was there in a graph database, and you could simply run, design and run the query. So you run the query in exactly the same way. And we have demonstrated that this is powerful enough to find real instances of real financial crime in the data that AUSTRAC has. On the other hand, it does something else that usually doesn't come together with security, which is privacy. So we know that in many countries, for example, in Europe, the data from the transactions of the various banks actually is pulled to one place and analyzed together, but this has huge privacy ramifications and of course creates a honeypot for hackers. This solution is fully privacy preserving, except for the identity of the accounts that match the crime typologies we are looking for. That information is delivered to AUSTRAC. Except for that, no information is given to anyone. So privacy together with security. And there are some theoretical works in academia that do both of these things, but what they don't do is the third item in our trifecta here, which is efficiency. So normally, if you look at academic papers about this, they try it on a few thousand accounts and a few thousand transactions, and it takes forever to analyze. Whereas we have a system that has been demonstrated to scale up to the entire size of the Australian economy, and we can run queries depending on their complexity in between minutes to hours. Whereas previously, in order to find something like the layering example that that I showed previously, that was a manual process that could take weeks if it is even done, because of the huge privacy implications. Usually, it's just not done at all. So how does it work? This so far seems quite magical. So let's say that this is the graph of domestic transactions. What I'm showing here in the 4 quadrants are Australia's big 4 banks. And let's say that the letters are various accounts and the arrows are transactions between them. And for our specific example, I'm going to choose a very, very simple example to work off of. Obviously, that is not the end-all, do-all of what FinTracer can do. So in our example, we have some account E. This is Jim's gym, and Jim got the government assistance. And we have another account I, which is a jump-off point to offshore accounts with known criminal ties. And we are trying to answer the question, is there a connection from E to I? It's difficult to see this even with a few transactions, just looking at it, but there actually is. Here's a connection from E to I, and if you found that one, congratulations, there are actually 2 of them. Here's the second one. So our goal is going to be to find that these connections exist without learning anything about these other connections that are in gray. And here's how FinTracer does that. So to demonstrate, I'm just going to unravel this network a little bit just so that it will be easier to see. And the magic is to do with what we call FinTracer tags. So a FinTracer tag is a very small packet of data. It's literally 128 bytes long. And we attach that to each and every account. It is managed by the bank that is also managing the account. That bank is the only bank that can see it. And the only party that can see it. Now, what these store is a bit. we've designed it so that it is impossible to store in the FinTracer tag any more information than just a yes, no. And that yes, no is encrypted, and it's encrypted in a key that is held only by AUSTRAC. Now, what I want you to convince yourself is that if we take these tags and we start switching them around between banks, no information is shared between any of the parties involved. Why is that true? Because, well, first off, the banks don't have the cryptographic keys. So no matter who gets what tag, they just don't know. They can't see into what's in the tag. And regarding AUSTRAC does have the key, but it doesn't actually own any account, so it doesn't have any visibility to the tags themselves. So it doesn't matter how you switch them around in the banks. With that in mind, knowing that nobody can see what's inside these tags, we in this talk are actually going to be able to see what's in. So let's put on our X-ray specs. We've just made these tags into transparencies. Like I said, they're going to just store one bit of information. So a clear transparency is a no, and a tick-marked transparency is going to be a yes. And the way to think about it is the ones that are tick-marked are like accounts that are of importance, of relevance relative to a specific query, and the other ones aren't. So initially, none of them is relevant, but what we'll do is we'll start the query by having AUSTRAC go to this particular bank and ask that bank to tag the account that belongs to Jim's Gym. Now, notice AUSTRAC doesn't do the tagging itself. It asks the bank to do so, and it doesn't even know which account belongs to Jim's Gym. Maybe there are multiple accounts belonging to Jim's Gym, and indeed AUSTRAC can say tag every account that got the government assistance. It doesn't matter. You can tag as many as you wish, and it's always the bank that does it. AUSTRAC has neither visibility nor ability to modify any tag. We are using, however, some public key cryptography, which is why the bank can set the tag, even though the bank can't read it. Okay, now the next thing that we're going to do is we're going to perform something called FinTracer propagation, which is the heart of the whole thing. Now you propagate over a graph or a network. Specifically, in this example, I'm going to show propagation over the transaction graph, but in real world queries, you propagate over other graphs. Like you can say, I just want the transactions that relate to the last month, or that are above a certain number of dollars, or that have accounts in a particular geography. Whatever is your condition, or sometimes you want to follow to send the tags in the reverse order to in the reverse direction to the money flow, and sometimes it doesn't even matter what the money flow is. So for example, if I want to check if two accounts belong to people who know each other, I can just check if there is flow between them regardless of its direction. But in this particular example, I'm going to use the transaction graph, and this is what propagation looks like. The bank just simply gave the tag to the next bank in line, to the next account in line. And the thing to remember is that this is not done just for the tick marked account. It's done for every account here. The banks don't actually know which is ticked and which isn't ticked. So they just hand it over between each other, and that's something that you can do without knowing what's in the tags. Let's try this one again, another propagation step. So that's another thing that we can do with the tags. We don't have to send them to just one other account. We can send them to multiple other accounts if there were multiple transactions. For the next propagation steps, I'd like to direct your attention to the two tick marks that are higher up on the screen, these two. If I now propagate, look at that, both of them converged onto this one account, which is why I said they're like transparencies. If I stack multiple of them on top of each other, it's enough that one of them is tick marked for the end result to be tick marked. That's something that requires more sophisticated cryptography. What we're using here is not just public key cryptography, it's what's known as homomorphic cryptography, and it's something that we can do. Last propagation step, this time I direct your attention to the bottom 2 ticks. And what happened is that they ended up marking our destination account here, this red account. Now, think what it means that this destination account is ticked. What it means is that the tick marks somehow managed to make their way all the way from the green to the red. How were they able to do that? They were able to do that because they were following the same path as the money flow, this path and this other path. That's how they got from there to there, which is why the fact that this is tick marked tells us that these connections exist. So now we know that the connection exists. Unfortunately, we're the only ones who know, because remember, the tags are not visible to anyone. They're encrypted, they're not visible to anyone. So how do we make the final answer known? Well, we have many different ways of how to do that in the full system, but in this particular example, it's very, very simple. AUSTRAC can simply ask the relevant bank for the tag value. This one tag value is sent to AUSTRAC. AUSTRAC decrypts it, sees that it's tick marked, and now there is a suspicion. And now AUSTRAC can do follow-up analysis. And some of this follow-up analysis might still be through the FinTracer system, might still be privacy preserving. Some of it might be conventional means. At this point, you can do whatever you want. Now, that was a very simple example. In practice, we can do a lot better. For example, we have support for what we call nonlinear operations. That's when you take several conditions and say, I want something, tell me which accounts match all of these conditions. So they're both this and that. And that's not needed for the basic functionality that I've demonstrated. But once you have it, you can suddenly describe arbitrarily complex typologies with as many distinct actors as you want, as complex interactions as you want. It suddenly all becomes possible. You can also ask arbitrarily complex questions. In that particular example that I just demonstrated, all we asked was, is there a connection? But you can also ask, how many hops does it take to get there? What are the accounts along the shortest path? Maybe I'm looking for a specific path. Maybe I'm looking for a path that has some friend of a known person of interest. And then I'd want to know, what is that path? What is that? Who is that friend? Etc. These are all types of questions that are very easy to ask and answer through the FinTracer system. And of course, as I already hinted before, you can do far more sophisticated result reading. In this demonstration, I just looked at one specific tag value, but you can also ask how many accounts that moved money offshore had tick marks. And if the answer is low enough so that the retrieval of the information is privacy preserving, I can say, well, give me the identity of just those accounts. And all of that can be done in a privacy preserving way. You don't need to retrieve all of the accounts, find out what they all are, and only then ask. So this is a method that allows the same kind of functionality in terms of querying without the data ever being shared between parties or pulled together. The data of the bank stays at the banks. And with that, I will return the floor to Carl for describing how all of that impacts us.
Thanks, Michael. So, as I stated at the outset, the major reason for attempting to create this type of technology was to enable analysis of the entire system, if you like, whilst preserving privacy because of the strong privacy legislation in Australia and, of course, the tipping off provisions. There are, of course, other reasons why entities and individuals don't like sharing data in any system. There are commercial and confidence reasons, of course. So there's a broader application, I think, than just beyond the circumstance where there are very strong privacy provisions in any given system. But clearly, if you find a way that enables system-wide analysis, that enables a range of other, I think, excellent outcomes in terms of understanding and therefore being able to mitigate risk within a financial system. I should say that this is by no means a capability that sits by itself and will resolve all the problems in terms of finding wrongdoing that one might have. What it does do is act like a highlighter, if you like. Identify areas where you want to focus your second order efforts, if you like, which means in circumstances where you have scarce resources, when you're looking at the operation of an FIU, then you know how to better allocate those resources with more chances of success in terms of finding wrongdoing. As I said, the privacy preserving aspect of it, I think, enhances acceptability from a system point of view, because people aren't having to compromise what is often seen to be very valuable data that they hold for themselves. I think, and some of this conclusion comes from an understanding that when you look at efforts within an FIU to identify a financial crime, there's a gravity that the enforcement end of the spectrum, if you like, always has. It's sexy to find wrongdoing and to take some sort of activity that ends that wrongdoing. What that means, I think, is some of the higher level analysis that should be undertaken around the system-wide risk that exists within a financial system. How much money laundering is there in a system? What percentage of financial transactions are associated with financial crime? None of these questions really ever get answered. And I think when you try to inform policy, being able to have better evidence to make conclusions around those things ends up with better policy being created. There's also a tendency to drive investigations from knowns, if you like. We know person X is suspicious. We look at person X and we track back in the data to try and determine what person X is up to. Or we know a particular type of typology, and so we look for that typology. When individual financial institutions are looking to produce suspicious matter reports, they go back to what they know is a suspicious matter, which means that we are less able to detect some new form of money laundering that doesn't exist in terms of a current understanding of typology. What this technology offers, I think, longer term, is the ability to start the investigation from the data and find the wrongdoer rather than the other way around, which means that you're potentially going to be able to find patterns in the data that suggest new forms of typology that will point to as yet unknown wrongdoers, and end up with a better analysis and a better outcome at the end of it. One other aspect is that reporting entities often complain, at least in the Australian system, I assume it's similar elsewhere, that they don't get good feedback for the efforts they've made in terms of providing suspicious matter reports so that they can fine-tune the suspicious matter report activity, so that they better understand what they should be putting in. Again, this capability, this technology would enable, I think, better feedback. It'd enable better focus for individual financial entities on where they should be looking, and in that sense would enable them to reduce their own compliance costs, to actually, what I would term, democratize the risk to some extent, in that a particular transaction within a financial entity may not look suspicious, but clearly this will identify that in association with other transactions it is, and therefore the risk for that financial institution will be reduced, and therefore presumably the compliance costs will be reduced. Michael, I just want to flick to the next stage. I've taken a little bit of conceit here. On the left-hand side, there's an SIU, which stands for Systems Integrity Unit. Of course, this is supposed to rhyme with FIU, but what I've suggested here, there are two particular functions that should be carried out in terms of attempting to find financial crime. Down one hand, and you have the pointy end, if you like, looking to get enforcement activity happening, direct investigations, and down the other end, I've put a list of things that I think are higher order analysis that sometimes get left out of the process because of the focus on the enforcement end, the gravity that the enforcement end has. It's a bit of a conceit on my behalf to put it in those terms. I'm not necessarily suggesting here that you should create another entity, but within the conception of what the activity of a financial intelligence unit or center should be, I think that higher order analysis, the system level risk analysis, is something that should have a greater focus, and that obviously a FinTracer-like capability would be something that would enable that focus. Thank you, Michael.
Right. Michael and Carl, thank you very much for a really rich presentation. It is exciting to look at tools that can provide us with improved data analytics and data insights while protecting privacy and the data better. With increasing fraud levels, we know we need to be far more sensitive about data protection. And to date, anti-money laundering in particular has been very data rich. And therefore, this is really very promising technology. Now, ladies and gentlemen, it was great to look at the very diverse group of people that joined us today for this webinar. There's a Q&A function. Please post your questions there. We've got the right people with us to answer them. But while you're thinking about questions, I want to turn to you, Vivienne, because I'm very interested in your views as a former bank supervisor, kind of listening to this presentation and looking at the power of those visuals provided by Michael and Carl. What are the key questions that arose in your mind?
Thank you, Louis. I actually have a question, if I put the bank supervisor hat on, to both Michael and Carl, and they were very welcome to share in these two questions. So maybe I should do them both together if they can jot them down. For Michael, what types of activities can FinTracer potentially be used for? And then for Carl, what do you think the benefits would be for individual financial institutions if such a system such as FinTracer was in play?
Thank you very much,
Michael,
Vivienne.
you can maybe go first.
Certainly. That's an excellent question. I am a data scientist, and as a data scientist, I firmly believe that anything has a footprint in behavior. So if you're looking for any type of intention, that will manifest as behavior. And in FinTracer, we have the ability to profile things based on their predominantly financial behavioral footprint. If you can specify what behavior you're looking for, then you can find it in the data. You can find where you have instances of it in the data. Now, sometimes this translation to what is behavior is more straightforward. Sometimes it is less straightforward. Sometimes you have to use various proxies or approximations. So, for example, we might ask if somebody is a beneficiary of a trust fund. We have a trust fund that we are worried, might be involved in something fishy. We're trying to see what who the beneficiaries are. Well, in normal investigation, you will have one bank that manages the trust fund itself and one bank that will manage the accounts of the beneficiaries, and therefore the link is cut. Neither of them can see the full picture. Neither of them has the information we need. But with FinTracer, we can have a FinTracer tag being propagated from the trust fund account to the beneficiary account, and we can immediately, implicitly have that identified. So that is a pretty straightforward example. If you're looking for something more sophisticated, like politically exposed persons, it's more of a question regarding how you define it. A very simple, very naive proxy would be, well, let's say that we have organizations that we want to monitor, and the people that receive wages from these organizations that are with a salary above a certain amount, they will be our PEPs. You can define that. That's a behavior, and FinTracer can send those tags over, and you can follow them. And the same is true for any kind of behavior you might be looking for, whether it's organized crime, money laundering, racketeering, um, anything to do with tender fixing, any type of financial activity. You can, if you have the ability to follow the money, then you have the ability to find it, and FinTracer gives you that ability to follow the money.
Fantastic. Carl, you want to add on the last part of the question?
Yeah, so in very simple terms, as I said before, because this capability enables visibility for individual financial institutions of activity across the system, that means their own ability to mitigate their own risk is enhanced. It highlights, as I said, where effort should be made in relation to investigations, SMRs and the like. And therefore, it should, for individual financial institutions, lessen their own costs because they're better able to identify where they should be putting their own resources. It would mitigate risk for them. Because it also has possibilities in terms of things like identity theft, it should also help them more quickly, if you like, identify when their own customers are facing that kind of problem, and to be able to act pretty quickly in comparison to existing systems to act to stop the transfer of money in circumstances where somebody's identity has been stolen, for example. So bottom line is reduce compliance costs, reduce risk, and therefore reduce the amount of money that individual financial institutions need to spend in those areas.
And if I may add one more thing, one of the wonderful things about FinTracer is that you can ask your questions in a piecemeal way. You can build them up like Legos. So no part of your query necessarily needs to be a full criminal typology. It might be just an element that you're searching for. So just the fact that somebody is a PEP isn't something that you want to advertise, but you might actually want to use that information as you're searching for a wider or a more specific query that is indicatory of something criminal. And what you have in FinTracer is the ability to ask a query and then not receive the result, but rather keep the result in the form of a FinTracer tag. Nobody knows what is in that tag, but you can use it in your next query. So results can come to AUSTRAC and to the banks. Result can reside only in the banks, or results can remain hidden and nobody knows them, and you can still use them later on. You're on mute,
Thank
Louis.
you so much. And Vivienne is keeping an eye on the questions in the Q&A, and I can see a number of them coming in. So Vivienne, over to you, and Carl and Michael, you'll have to probably keep it fairly short in order to accommodate the questions. Vivienne.
There are two questions that I'm seeing that would, the second question I think you need to take first, because that is directly linked to the PAP issue. So it comes from Christina Wolf, and the question is tag generation automated and near immediate at each bank? For example, tag Y, if trust fund account is XYZ, Tag Y if account is for politically sensitive person. Tag Y if account salary discloses over a certain dollar amount. I think maybe, Michael, if you would like to take that question, and then there's one for Carl, maybe. Just curious if the solution is currently being used. Do you have a view of how accurate are these solutions? Are there any potential risks associated with the solution? And yeah, we can take those two questions.
So regarding the first question about how automatic it is, one of the problems of working with banking data is that every bank stores the data in completely incompatible ways, different systems, different schemas, different everything. And we did not want to force the banks to use one schema and put all of their data in one schema for FinTracer. That would not have been realistic to do. So instead, what we did was we built the system as an open ecosystem. The very most basic bits of information about transactions, like from which account to which account, when, and to what amount, that is in a table that needs to sit in a standardized way, in a standardized place. Other than that, everything else can be placed in our database in an ad hoc way. So if I'm looking for all accounts related to trust funds, that is information that the banks know, but is not standardized inside FinTracer. So the way to get that information would be for AUSTRAC to say to the bank, I'm now going to ask about trust funds. Please create a table telling which accounts are trust funds, and then that table is created. It's still completely inside the bank. Nobody can see it. And then a query can run and use that information. When the query runs, it runs completely automatically. It uses that data and moves on, and it's completely hands-free. The putting of the data into the FinTracer ecosystem is a manual process, which allows it to be so much more flexible.
Well, to answer the second question, given the time, I'll be very quick. In terms of is it currently being used? The situation with AUSTRAC was that it took the concept to proof of concept stage. It is not currently being used by AUSTRAC. AUSTRAC determined that it would open source the capability, and therefore it's available, as Michael indicated, for use by anybody. In the proof of concept process, AUSTRAC data was used, and this capability was able to find the same financial crime issues that had been found by AUSTRAC using its traditional approach, plus some. In terms of potential risks, I guess the biggest risk is that you don't get the outcome you want. Clearly, because of the privacy enhancing nature of it, it's very little risk in terms of unwelcome outcomes. It'd just be the situation that you'd spend a lot of money and you don't get the outcome. That's all indications are that that's not a risk. Michael, did you want to add to that? And I know there's another question from
I thought that was nothing to add from me.
Thank you, and thank you also to Maria for those questions, and to Christina, who asked about the tags, but who then also followed it up, just for clarification, Michael, whether the table will be point in time or and not updated over time.
The table is a table that the banks manage. Each bank manages their own tables. Nobody else has access to this data. Nobody else can see or modify the data. So in the end, it is the bank's decision whether they want to continuously update anything. Some tables can be continuously updated. Others would not be. The only table that should be continuously updated definitely is the transaction table with the very basic transaction details. And even for that, I mean, it's not like this system is meant as a real-time system. You don't update it on a minute-to-minute basis. When we were developing this for AUSTRAC, it was, I believe, supposed to be updated on a monthly basis.
Thank you. And I assume that with public-private partnerships in the intelligence space proliferating, that they would collaborate to ensure a sufficient measure of standardization. And then within that individual banks might have own needs that they may embed in their approach. We have just had a question from Terence, and that is whether the adoption of ISO 222 helps FinTracer with a standardized data set.
I'm not an expert on ISO 222. In terms of standardization, maybe I'll share the screen again. So this is what we call an excellent question, because I have slides. The way that FinTracer currently works in terms of architecture is it has a front end that is super user friendly, because it's built as a researcher would like to see it, with a Python front end, a Jupyter front end, but all of the actual work happens behind the scenes, connected only by a message queue through a set of servers, each server managed by a different node, which would be a bank or AUSTRAC, as may be the case. Now, operations over here are the heart of the system. We've implemented them in Go and in CUDA, but in terms of the actual data, everything sits here in a Postgres SQL database. So this is as easy to accommodate as can be, and in terms of the deployment, these are all OCI instances, again, as easy to accommodate as can be. So the idea was to make it as simple and as standardized as it can possibly be. If you can do it in SQL, we can work with it. Carl, do you want to add to that?
The short answer is no, Michael.
So that is not only an excellent question, it's also an excellent presenter who actually has a separate slide prepared in order to respond to such a question. We have further questions coming in. There's Maria Puku asked whether the tag criteria are flexible or fixed, i.e. the factors considered in the tagging, such as the bank account linking to a social club with multiple individuals.
So we think of the FinTracer system as though it was a programming language. The graph queries, you can think of them as commands in a language, and that language has underlying variables. Those variables are the FinTracer tags. So while the variables may mean different things in different contexts, their meaning is really dictated by the commands that you run. They're dictated by the queries. So for every time that you run a query in FinTracer, you're creating new tags, and those tags mean whatever you want them to mean for that specific query.
Excellent, thank you. Now, Carl, just looking at it from a practical perspective, if a country is interested in this type of technology, which agency, to your mind, would be would best lead setting up such a solution? Would it be the bank supervisor? Would it be the bank industry itself and its representative body? Would it be the FIU? Would it be an intelligence public-private partnership? What given your experience, what do you think would work best?
I think, Louis, much depends upon the system that you're talking about. I can imagine in smaller financial systems that you'd want to have a central entity that was well resourced to be able to carry out the activity. But that said, it'd probably have to be self-funding, so you'd probably want a public-private partnership to do it. I think because I have this attraction to the sort of system level analysis concept, and I think something like a bank supervisory entity or some sort like that is a good place for it. I think if you put it in an FIU, my experience has been, as I said, that the effort and resources start to get pushed down towards the pointy end, if you like, for the big attractive effort to shoot the elephant and make headlines. And some of what I think are very important higher level analysis doesn't take place. And from that point of view, something like a supervisory body or similar, depending on the environment, would be the best place for it from my point of view.
Thank you. I'm looking at the time and we should start wrapping, but I think perhaps just, Carl, very, very briefly, we've really focused on banks and bank accounts and transactions between banks in the presentation. Is there any way to bring non-banks into such a system? Is it possible to apply it? Is that something that you've given some thought before?
Yes, and Michael can answer the technical question if you like. It's applicable, I think, in any scenario where you've got encrypted distributed data sets and you want to carry out analysis. So there's a broad array of potential activity that it could undertake. I think Michael, and I'll give Michael a chance to add his bits in a second, but I think the thing to keep in mind is that it's not like you can take the FinTracer algorithms that were developed for Australia and immediately put them into another country and they will work. Each time it has to be bespoke. And I think the same would apply to other circumstances where you're not talking about pure financial data. Sorry, Michael, over to you.
So, Michael, briefly, do you think something like that is feasible?
So, when we talk about putting a data that is not financial data in the system, we can mean several different things. So first off, I've seen interest in implementing this system completely outside of AML. So to try and find things like identity fraud, that kind of thing. So that would be just a completely separate usage. But even if we're talking about the usage that we've discussed here, where there are nodes for the banks, the question is, I have data that sits elsewhere. Maybe an insurance company has it, maybe a lawyer has it, maybe a government agency has it, and the question is, how do I use that as part of my queries? Well, in some cases, there are no privacy implications, so you can give that information to one of the parties. Let's say you give that information to AUSTRAC and it can enter it as part of the ecosystem of FinTracer. If you can't do that, if we are talking about a data that must remain private, so let's say a government agency has some data that links I don't know, a company account with its owner account, which nobody else has, and let's say that it's private information, they can join up as another node in that FinTracer architecture.
Excellent.
Like we had an AUSTRAC node.
Thank Thank you so much, Michael. I'd love us to spend more time on this, but I realize our time is drawing to a close. Perhaps just as a final, Michael, kind of, what do you see as the next steps for FinTracer?
Oh,
In a minute or two.
There's just so much. There's just so much that still needs to be done in FinTracer. What we've built at AUSTRAC is a prototype with some known limitations that we know that the next step would be to move beyond them. Things like we want to give the banks more control about what runs in their node. It's not just the case that AUSTRAC defines a query and immediately it runs everywhere. We wanted an authorization mechanism. We have it designed, we just didn't implement it yet. Like Carl said, we designed this with the Australian legal system in mind. That's why the algorithms look the way that they look. That's why the design is the way that it is. But obviously, when you switch to a different country with a different legal system with different restrictions, you might want to adjust such things. At this point, I think it's about having the rubber meet the road. I put on the chat the links. These are links for further reading for people who want to look more closely at this and perhaps think about implementing this in their specific scenarios. Definitely, when you try to do that, you will find that you will want to tweak some things here and there, and this is definitely something that we want to hear about. We want to be part of.
Excellent.
I think that's true for all of us here.
Thank you so much, Michael. Then just very brief final takeaways, views, Vivienne and Carl, in 20-30 seconds.
Right, I'll be very brief. Maybe two key takeaways from my side. This demonstrates for me that if our regulators, our supervisors and techs or industry collaborate, we can actually have quite a powerful input in relation to ensuring that we can hold people accountable. And that is what was demonstrated for me this afternoon. And secondly, I would be very keen after this to still collaborate with you, because I could see all the other kinds of use cases outside of necessarily AML, CFD, etc. And not only in relation to financial crime, but also systemic issues that Carl has mentioned, and also around clean and efficient government. So we'll be taking the conversation further.
Excellent. Thank you, Vivienne.
Thank you so much.
Louis, I'll finish not so much with the summary, but put a concept out there. If you can convince the players in a regional context, for instance, Louis, I know you've done a lot of work in the South Pacific in recent times. If you can convince the players in that kind of environment that this is truly privacy preserving, you end up with the potential possibility for analytical capability that is regional. And will certainly help some of the smaller nations in that kind of setup who can't afford to do this type of thing themselves.
Excellent. Thank you so much, Carl. Join me in thanking our speakers, especially Michael and Carl. It's now approaching midnight in Australia. Vivienne, thank you for a splendid job for you from South Africa. And with that, we hand to Kelly from the Cambridge suptech Lab. And thank you to you for hosting us, and to the fantastic tech team, Christiana, for keeping all of us on track, and for Elia, who did a marvelous job bringing everything together. Over to you, Kelly.
Thank you, Louis. Thank you, everyone. What a great day to start with the second day of suptech Week. Truly insightful perspectives today. They set the tone for a day filled with impactful conversations. So thank you to everyone that joined this session. As we continue today, I encourage everyone actually to engage actively. I've seen the chat. Share your thoughts, participate in the polls, connect with thought leaders and peers. Don't forget to explore also the virtual exhibition booths. You'll find innovative tools there, solutions shaping financial supervision. And if you haven't already, please sign up also for the AI Bootcamp on Thursday. Fantastic opportunity to gain hands-on experience in implementing AI strategies. So the next session will begin shortly. Stay with us as we're moving on. Thank you again, and look forward to seeing you the upcoming sessions. Thank you all.